In this video, I will share how I passed the GCP Professional Cloud Architect Certification exam in the first attempt. I collect my learning path, study materials, and test experience immediately after the exam, so I hope the information I provided here may help others earn this one of the most valuable cloud certifications. After I got my certification, the first question I got from others is how difficult the exam is. The short answer is very difficult, but it is manageable. Let's take a look at the exam overview on Google Professional Cloud Architect Certification page. At the time of recording this video, the GCP Professional Cloud Architect exam is a 2-hour exam with 50 questions. All questions are multi-choice and multi-select. I took the test remotely. The questions in the exam focused on the real scenario-based use cases and your hands-on experience in GCP. Take some time to go through this page on exam guide. Review the sample case studies and other resources for this exam. From the difficult level standpoint, I think the exam is more difficult than AWS Certified Solution Architect Associate exam I had before, but I feel it at the same level as AWS Certified Data Analytics Specialty Certification exam. Now, let's talk about the learning path and the study materials for this exam. There is no prerequisites for this exam, but GCP expects you have hands-on designing and managing solutions using the GCP and software development experience for this exam. You can find many good structured online courses for this exam. Take the free trial opportunity of those courses to find one fit with your learning style. At the time of recording this video, GCP provides free training courses for its certification exams. After you click Register Now, you will go to the certification journey page. Click the Register Now button. Select the certification you will tag in the registration form. After you submit this registration, you will receive an email from Google with Coursera and Quick Labs offers to help you prepare for your certification exam. It is a 6-week preparation for the exam with 1 month free access. If this offer is no longer available when you are viewing this video, you can go to the Coursera directly to search for this course. The course's name is Cloud Architecture with Google Cloud Professional Certificate. The course will provide you comprehensive information on GCP and hands-on labs in the Quick Labs. There are 6 courses in this professional certificate, with the information such as core infrastructure, foundation, core services, design, and process. The last one, preparing for the certification example course, is really helpful. It provides good architecture solutions for sample, case studies, and the sample example questions with the answers. So take the advantage on this course. The second thing you should prepare for this exam is hands-on experience on Google Cloud Platform. This exam will expect you can set up and run GCP services not only through the console, but also use the command lines like gcloud command, gsutil command, and kube control command. You can get the hands-on experience from the hands-on laboratories in the certification course or practice with the Google Cloud free tier. Go to the Google Cloud documentation page. You can start the free tier by clicking Get Started for Free button or clicking the Google Cloud Platform free tier. Two sections in this page you should pay attention. You should definitely practice them before your exam. One is in the top user cases with the detailed instructions both on the console and command lines. The other one is the best practice with the architecture diagram, tips, and detailed explanations on the solution services. Now let's touch on the software development experience you should need for this exam. This exam does have some questions on software development, such as software development life cycle, continuous integration and continuous deployment, CI/CD, testing, and resilience. You should also understand the data protections and regulatory compliance with GCP, for example, the PCI DSS, GDPR, HIPPR, and COPPA. Please click those links in my blog to get a deep dive on those topics. I also collected the GCP Professional Cloud Architecture Certification learning videos. Those list is from Google Cloud Next. If you don't have time to read all the GCP documentation, feel free to review those videos before your exam. Let me also share my lessons learned from my online exam experience. You will receive either pass or fail at the end of the exam. There's no official passing score from Google. It will take at least 7 to 10 days for Google to evaluate your remote test result before Google releasing your certification information. During my exam, I didn't see any long description questions like I saw in the AWS CDA exam, so don't rush in to complete the exam. You should have enough time to read and understand each question. I had the question of GCP case studies at the beginning of the exam. Those questions were really hard and around 24% of the exam. In order to not get stressed out at the beginning, spending more time learning GCP case studies. So you should have the best solution architecture, the faster solution such as the lift-shift solution, and the solution for the future growth ready before the exam. If you are stumbled on something, don't spend too much time on it. Just flag those questions for later review and select your best guess. Even most cloud providers using the similar concepts, but don't confuse GCPs with others. You should get a deep understanding of core concepts like Google computing, among the GCE, GKE, GAE, and functions, networking such as VPC, load balancing, and network connection, cloud IAM, storage such as GCS and disks, and database such as the Cloud SQL, Spanner, FileStore, Bigtable, and BigQuery. I also provide my sample last-minute cheat sheet for the GCP Professional Cloud Architect Certification exam. Take a look on the last-minute cheat sheet. I hope that helped you. Now, this is all my experience, and I hope it will help you to study more effectively, and good luck on your exam. In my blog last-minute cheat sheet for GCP PCA exam, I list 4 decision trees to help you to choose the right services in the exam. Let's walk through the first one, storage and database decision tree. The decision tree starts with the questions: is your data structured? If it is not, choose cloud storage. If your data is structured, does your workload focus on analytics? If it does, you will want to choose Cloud Bigtable or BigQuery, depending on your latency and update needs. Otherwise, check whether your data is relational. If it is not relational, choose Cloud File Store. If it is relational, you will want to choose Cloud SQL or Cloud Spanner, depending on horizontal scalability. You can go to the following 2 GCP web pages to review GCP storage products and GCP databases options. Let's quickly go through them. The first one is the storage products. You can see the use cases for each product. For example, cloud storage for object, blob storage, archive storage, the persistent disk and local SSD for block storage. By the way, my blog lists the comparison among the storage options, and I will make a video to talk more details among persistent disk, HDD, and SSD. You can see the file store for file storage. Mobile apps use cloud storage for Firebase. And you will see the transfer service to transfer data from on-prem to cloud or cloud-to-cloud transfer. By the way, I didn't see any collaboration questions in my exam, but you might want to know the high-level concept of the collaboration products just in case. The second page is on the databases options. The GCP database servers for the relational and non-relational databases such as Cloud SQL, Cloud Spanner for relational databases, Cloud Bigtable, Cloud File Store for NoSQL databases. I like this comparison table on what are you building. For example, if you need global data distribution and scale insurance for the relational databases, then you should choose Cloud Spanner. It also lists the other features on those services such as replica consistency, the multi primary joins and complex queries, real-time sync. So this is to give you an idea how to choose the right service for your database options. You can also go to the GCP documentations to review the details on each GCP service. At the last, I summarized GCP storage and database decision tree with the keywords and the use cases for you to easily remember for the exam. The options divide into object, relational, non-relational, and data warehouse. For example, the cloud storage is for unstructured data, archive, temporary storage, It is the lowest cost storage option for up to X bytes. The use cases include images, media serving, data lakes, or backups. A Cloud BigQuery data warehouse service is different than the other OLTP service in this table. It is for OLAP. Well, you got the point. Pause this video if you need more time to review the keywords of each service. Thank you for your time and see you in the next lecture. In my blog Last Minute Cheat Sheet for GCP PCA exam, I list 4 decision trees to help you to choose the right services in the exam. Today, let's walk through the second one, Computer Options Decision Tree. The decision tree starts with the question, are you developing the mobile HTML app? If so, choose Firebase. Otherwise, if you are developing the event-driven app, then choosing Cloud Functions. If the application has some specific requirements such as a specific OS or kernel or GCP access, or it requires you to lift shift from on-premise to public hybrid or multi-cloud deployments, or the monolithic workloads, use of protocols beside HTTPS, then you should use the Google Compute Engine, GCE. If you plan to use Kubernetes as a orchestrator or the apps needs containerization, then choose Kubernetes Engine, GKE. Otherwise, you use GAE, Google App Engine the platform as a service option to build a highly scalable web and mobile end applications on fully managed platform. Again, I summarize the computer options decision tree with the keywords in the use cases for you to easily remember for the exam like I did for the other decision trees. You can find the details of the comparison among GCP compute and processing options in my blog. I include the Google Cloud Run in this table, even though I didn't have any questions on this one in my exam, but since the Cloud Run was GA at the end of 2019, I think you will start to see it in the exam. Cloud Run offers a native serverless experience that lets you to go from the container to URL within seconds for increased developer velocity. The keyword is serverless container. There are 4 categories in compute and processing options: GCE in infrastructure as a service, GKE and Cloud Run for containers. GAE has standard and flexible options in platform as a service, and Cloud Functions in functions as a service. I collected the features comparisons such as scaling, language support, background processes, request timeout, and the others to help you select the right service in your exam. For example, if you just want to focus on the application development, but you do need to install the third-party binaries, then you should use App Engine, a fully managed serverless platform, but with a flexible option to support custom runtimes. Also, if you want to learn more on which serverless compute platform you should choose among Cloud Functions, Cloud Run, and GAE, Then take a look at the serverless options decision tree. It will help you to understand the specific requirements such as the stateless HTTP versus event-driven, need Kubernetes versus configurable hardware, custom language, and system binary, or the unit deployment. Well, this is what we have for today. Thank you for your time and see you in the next lecture. In my blog Last Minute Cheat Sheet for GCP PCA exam, I list 4 decision trees to help you to choose the right services for the questions in the exam. Today, let's walk through the third one, Cloud Load Balancer's decision tree. What is a load balancer? A load balancer distributes the user traffic across multiple instances of your applications. Use a single IP address to serve as the front end and auto-scaling the back end to serve traffic. It is also integrated with Cloud CDN for cached content delivery. It allows you to set up the backend traffic subject to firewall rules. Google provides the following cloud load balancing options. Global load balancing for when your applications are available across the world. Regional load balancing for when your applications are available in a single region. External load balancing for when your users reach your applications from the internet. Internal load balancing for when your clients are inside of Google Cloud. Cloud load balancing supports HTTP, HTTPS, TCP, and UDP traffics. Let's take a look at this summarized GCP Cloud Load Balancer types table, including whether the load balancer uses an internal or an external IP address, whether the load balance is regional or global, and supported pass-through or proxy-based load balancing and traffic types. So you can set up global load balancing on HTTP, HTTPS, SSL proxy, and TCP proxy. TCP UDP traffic is always set up with the pass-through regional-based load balancing, no matter the traffic comes from external or internal. Based on the summary table, now let's move to the decision tree. The decision tree divides the load balancing into external and internal. Then, based on the traffic type your load balancers must handle and the questions related to, such as SSL offload, global load balancing, and preserved client IPs to determine which load balance should choose for your application. So the decision tree will help you to choose exactly what you need from cloud load balancers. Please check out my other decision trees videos and my blog for more help. Please subscribe to my channel for more great cloud learning tips. Thanks for watching and see you next time. In my blog Last Minute Cheat Sheet for GCP PCA exam, I list 4 decision trees to help you to choose the right service for the questions in the exam. Today, let's walk through the first one, Cloud Network Connections Decision Tree. Google provides Cloud VPN, Cloud Interconnect, and Cloud Peering for cloud network connections. Cloud VPN and Cloud Interconnect are the Google Cloud products for cloud network connectivity between your on-premise network and Google Cloud, or from Google Cloud to another cloud provider. Cloud Peering is the option for connecting Google G Suite and Google APIs. Let's take a look at these products. If you need a private-to-private connectivity, then Cloud VPN is the best choice. Cloud VPN securely connects your peer network to your VPC network through the IPsec VPN connection. Traffic traveling between the two networks is encrypted by one VPN gateway and then decrypted by the other VPN gateway. This protects your data as it travels over the internet. You can also connect two instances of Cloud VPN to each other. Each Cloud VPN tunnel can support up to 3 GB per second total for the ingress and egress. Cloud VPN supports IKE v1 and IKE v2 using the shared secret. Google Cloud offers two types of Cloud VPN gateways, HA VPN and Classic VPN. Here is the comparison table between HA VPN and the Classic VPN. Pay attention to SLA and routing options supported features. Both offer 99.99% SLA. HA VPN supports only dynamic routing with BGP, Broad Gateway Protocol, but Classic VPN can support either static and dynamic routing use BPG. You can configure HA VPN for more bandwidth. It is mentioned in the Google documentation with the example on how to configure HA VPN gateway with the 10 Gbps throughput. You can configure one cloud router, 4 HA VPN gateways with 2 tunnels apiece for a total of 8 VPN tunnels in 8 total BGP sessions. Now let's move to the second cloud network connection option, Cloud Interconnect. If you need an enterprise-grade connection to Google Cloud that has a higher throughput, you can choose Dedicated Interconnect, which creates a dedicated connection, or Partner Interconnect, which uses a service provider to connect to VPC networks. Here is the comparison table between Dedicated Interconnect and Partner Interconnect. Pay attention to features. You can see the interconnect options are not through the public internet. Supported bandwidth, dedicated interconnect have a maximum of 8 times 10 Gbps or 2 times 100 Gbps. Partner interconnect only has the supported bandwidth with the capacities of 50 Mbps to 50 Gbps for each interconnect attachment. The BGP configuration is set up between your on-premise routers and the cloud routers. The encryption is on application level encryption, which is different than what we see in the cloud VPN. The last cloud network connection option is cloud peering. If you need to access only G Suite or supported Google APIs, you have to connect through the cloud peering. Peering doesn't produce any customer routes in a VPC network. Traffic sent from a resource in a VPC network lives by way of a route whose next hop is either a default internet gateway, for example, a default route, or cloud VPN tunnel. There are two peering options, direct peering and carrier peering. Direct peering enables you to directly connect with the Google Cloud at a Google agent location. Carrier peering enables you to peer with the Google by connecting through a support provider, which in turn peers with the Google. Both products give you access only to G Suite and supported APIs and don't provide access to VPC networks and VMs in Google Cloud. With all the above overview on GCP Cloud Network Connections products, let's move to the decision tree. Now, it's time to use the decision tree to choose the network connection product to connect your applications to Google Cloud. You may want to ask simple questions such as, do you need to access a private compute resource on GCP? Do the bandwidth and performance of your current connection to the Google servers currently meet your business requirements? Do you encrypt sensitive information at the application level? Do you already have or are you willing to install and manage access and routing equipment in one of Google's point of presence POP locations? So understanding exactly what you need from the network connectivity is just as important as understanding what each of the cloud network connection products does best. Please check out my other GCP decision trees videos and my blog for more help. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Let's talk about GCE storage options today. I mentioned I will make a video on this topic in the GCP storage and databases decision tree of the last-minute cheat sheet for GCP PCA exam. Google Computer Engine offers several types of storage options for your instances. Disk options for block storage, cloud storage buckets for object storage, and a file store for the file storage. In here, I highlight the keywords of these storage options for the exam. Disk options have a persistent disk, local SSD, and RAM. Persistent disks are durable network storage devices that your instances can access like physical disks in the desktop or the server. The data on each persistent disk is distributed across several physical disks. When you configure a zone or regional persistent disk, you can choose either standard persistent disk, balances the persistent disk, or SSD persistent disk. Standard persistent disk is backed by a standard hard disk driver. The other two options are backed by solid-state drivers. Local SSD is physically attached to the server that host your VM instance. Local SSD has a higher throughput and lower latency than the standard persistent disks or SSD persistent disks. The data that you store on the local SSD persists only until the instance is stopped or deleted. Keywords for the exam are higher throughput, lower latency, data lost if the instance is terminated. With these disk options, you can mount a RAM disk within the instant memory to create a block storage volume with a higher throughput and a low latency. RAM disks work well when your application expects a file system structure and cannot simply store its data in the memory. RAM disks alone do not provide any storage redundancy or flexibility, so it is best to use RAM disks in combination with other instance storage options. Now let's take a look at the object storage. Cloud storage buckets are the most flexible, scalable, durable, and cost-effective storage option for your VM instances. If your apps don't require the low latency or high throughput, then you can store your data in a cloud storage bucket. The last one is a file store that provides high-performance file storage. You can mount a NAS file share on a VM instance. Now, let's move to the comparison of these storage options. Again, I highlight the keywords to choose the right option for the questions in the exam. Let's look at the capacity. Each persistent disk can be up to 64 terabytes in size, so there's no need to manage arrays of disks to create large logical volumes. Each local SSD is 375 GB in size, but you can attach a maximum of 24 local SSD partitions, so that gives you a total of 9 terabytes per instance. Cloud storage buckets give you almost infinite storage. On the scope of access, you can configure a zone or regional persistent disk. Regional persistent disks provide a durable storage and the replication of data between two zones in the same region. Local SSD provides local block storage directly attached to the VM. Cloud storage buckets can provide worldwide accessibility and worldwide storage locations. Performance. Local SSD provides the fastest performance among other disk options. Only persistent disks can be used as boot disks. For example, GCE instance automatically delete boot disks when their instances are deleted by default. So to keep the boot disks after instance deletion, then you should use no boot disk auto delete option to disable. So you can see the command for GCE disk options are gcloud, but for cloud storage bucket is gsutil. Only the local SSD has no data redundancy feature. Computer engine automatically encrypts your data before it travels outside of your instance to any storage options. You can control the encryption keys with your own encryption keys, except for the local SSD option. Now you may have the question on which GCP storage options I should pick up for SAN or NAS storage. If you confused between SAN or NAS, don't worry. Here's the explain. SAN stands for Storage Area Network, which is a tightly coupled network of multiple devices that work with the block-based data. So the persistent disk is a good choice for SAN. NAS stands for Network Attached Storage. It's a single storage device that serves files over Ethernet. So you can choose either file store, Google Cloud Storage, or persistent disk for NAS. The cost-effective option should be Google Cloud Storage. If you need to mount file shares on clients in a remote network, then use a file store to achieve this. The last one is how to transfer the data to GCP. You can use online transfer to move data to Google Cloud Storage via the network. But for big data transfer, such as from on-premise to the GCP, then choose the transfer appliance. From cloud to cloud, such as between the Google Cloud storage buckets, from AWS S3 to GCS, or HTTPS locations to GCP, then choose the transfer service. Please check out my other last-minute cheat sheet videos and my blog for more help. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Today, let's go through the cheat sheet of Google Cloud Services for Big Data Analytics. I used this data lifecycle solution as my last-minute cheat sheet for both the GCP PCA and the PDE exams. I strongly recommend you to read the whole article. I will point out the key points for both certification exams, and I will make the follow-up last-minute cheat sheet series of the service that's lead to deep dive for the exams. The Google Cloud provides a 4-steps data lifecycle. Both the certification exams will test your understanding on these 4 steps and choose the right cloud service in the different user scenarios. Let's open the Google Cloud products list in another browser. I'll circle the service that appear in my certification exams for your reference. In the ingesting app data, one of the important app data is log data from apps running on Google Cloud. At the time of recording this video, Google certification exam still using StackDrive. StackDrive has monitoring, logging, trace, error reporting, and debug. I highlight the key points to remember for the exams: monitoring, which has the alert included, logging for the real-time logs, error reporting for the application errors, debug for debugging code in production, tracer for find performance bottleneck. You will also have the questions on how to use the logging or monitoring agents in the PDE exam. In this section pops up for real-time messaging. While GCP PCA exam focuses on the data flow architecture, for example, ingesting data from PubSub, transforming data on data flow, then loading the data on BigQuery for analytics. I highlight here that PubSub and the data flow, they can work together to strict message ordering. But in the PDE exam, we'll test your ability to design the data pipeline and the processing solution, so I will make another cheat sheet on the PubSub for PDE exam. Move to the next one, how to ingest bulk data and compare the difference of 4 ways to transfer data. In general, if you see question about transforming 10 terabytes data from on-prem to Google Cloud, the fast way is to use a transfer appliance. If you make a backup from another GCP bucket or AWS S3, then use a storage transfer service. BigQuery Data Transfer Service is used to transfer data from another Google SaaS, for example, Google Ads, YouTube, to BigQuery for analytics. gsutil command is usually used to transfer of large numbers of files by using the multi-threading option for less than a few terabytes of data. Now at step 2, store data. For details of storage and database decision, please review the video GCP PCA last minute cheat sheet on storage and database decision tree. You will have questions on choosing the right storage class from Google Storage. So please spend some time to understand each store class's availability and its cost. There are two choices for relational database, Cloud SQL and Spanner from Google Cloud. Highlight the key points for PCA exam. Cloud SQL supports workloads up to 30 terabytes for both MySQL and PostgreSQL. You can install the database in the Google Computer Engine if the version number isn't supported by Cloud SQL. I did have this kind of question in my PCA exam. The key point for the Spanner is that Spanner can horizontally scale out. Now move to NoSQL databases. Key points for Bigtable: consistent, no latency, and high throughput for terabyte to petabyte scale workloads. For the PCA exam, you only needed to understand Bigtable's use cases. For PDE exam, you needed to understand the schema design such as 12 verse wide schemas and the best practice on the Bigtable. The other NoSQL choice from Google Managed Service is FileStore. FileStore has the native and data store modes. At the time of recording this video, Google certification exams still using data store in the exam. I'll make a cheat sheet on the two modes and the difference between Bigtable and data store. At step 3, data process and analyze, Google provides the comparison among Cloud Data Proc, Cloud Data Flow, and the Cloud Data Prep. The information listed in the article is not enough to pass the PDE exam, so I will make the cheat sheet on these 3 services. The same thing on BigQuery. We do need to dive deep on the BigQuery to pass the PDE exam, so stay tuned for the BigQuery cheat sheet. Understanding data with machine learning provides a good instruction on each machine learning API for GCP PCA exam, but it is not good enough for the PDE exam. Again, please stay tuned for the video of machine learning cheat sheet. The last step is to explore and visualize data. You only need to understand the basic knowledge on Data Lab, Looker, and the Data Studio. To incorporate all of the above steps and operate the data workflow, you will use the orchestration service. Any question you see in the cert exams on the data workflow orchestration, The correct answer will be Data Composer. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Thank you. There are 3 options for using relational database services in Google Cloud: using Cloud SQL, Cloud Spanner, or hosting the database on a VM using the GCP. If your relational database requires special operating system, custom database configuration, or special backup requirements, then you should host the database on a VM using GCP. Use cases fit spanner-based are sharded RDMS, scalable relational data, require manageability, or HA, multi-region support, or strong consistency. Otherwise, use Cloud SQL to support workloads less than 30 terabytes relational database. There are 4 options for using NoSQL database services in Google Cloud: using Cloud Bigtable Cloud File Store, HBase on Dataproc, or hosting the NoSQL database on a VM using GCP. If your NoSQL database requires a special custom setup or lift and shift NoSQL database, such as MongoDB or Cassandra from on-prem to the cloud, then you should host the database on the VM using GCP. There is another situation. If you require transactional consistency, the database might change. You need an adaptable database, or you need to scale to 0. You want a no maintenance overhead scaling up to terabytes. Then consider using the Cloud File Store. If you don't require transactional consistency, or you need HBase replacement in the cloud, you want a consistent sub-10 millisecond latency for handling millions of requests per second, you might want to consider Cloud Bigtable. If you just need to lift and shift HBase from your on-prem Hadoop to the cloud, then you can deploy HBase in Dataproc. By the way, the difference between BigQuery and Bigtable on handling analytical operations is BigQuery provides a sub-second query response time and a high concurrency. Bigtable provides a consistent sub-10 millisecond latency for handling millions of requests per second. Now let's do a comparison of Dataflow and Dataproc. Both are data process servers from Google Cloud. Cloud Dataproc is recommended for existing Hadoop Spark applications or machine learning and data science ecosystem or large batch jobs with printable VMs. Cloud Dataproc doesn't support the streaming process like Dataflow does. Dataproc does not natively connect to PubSub, but PubSub can use a single endpoint with the Dataflow to process the messages. And Dataproc requires a DevOps approach, but Dataflow is a fully managed service. Now let's take a look at the difference between Dataflow and Dataprep on data preparation, transformation, or cleansing. Dataflow does not provide anomaly detection. Dataprep does. Dataprep can be used to handle schema changes by data analysts without any programming knowledge, but through the GUI. Dataflow requires programming knowledge on Apache Beam SDK. Now let's compare the difference between Kafka and PubSub. Kafka and PubSub are very similar to each other. PubSub is Kafka's alternate solution in GCP with no ops and serverless. I provide the comparison between Kafka and PubSub here for your reference. If you are unfamiliar with Kafka, then you should at least learn Apache Kafka's architecture and concepts from Apache Kafka's website. The first difference is message delivery. Kafka promises to deliver messages exactly once. PubSub guarantees at least once delivery, but PubSub can work with data flow for exactly once delivery. The second difference is the message retention period. Kafka can consume messages published longer than 7 days ago. PubSub's message retention ranges from 10 minutes to 7 days, but you can store the post-historical messages in a database such as Cloud Bigtable or Cloud BigQuery data warehouse. The third difference is on log compaction or random access. Kafka's log compaction ensures that Kafka will always retain at least the last known value for each message key within the log of data for a single topic partition. There's no equivalent feature in PubSub, and also the compaction requires explicit reprocessing of messages or incremental aggregation of state. However, PubSub does provide replay and purge messages. You can consider using seek functionality to random message access. The seeking to a timestamp will discard the acknowledged messages manually after a retention period. The last one is on message ordering. Kafka provides keyed message ordering to promise the message ordering within a single partition of a topic. PubSub has an ordering key to guarantee the messages successfully published by a single publisher for the same ordering key in the same region. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to my channel. Let's go through the last main cheat sheet of security in the GCP. You can use this cheat sheet for your GCP PCA and PDE exams. The first one is Identity and Access Management, Cloud IAM. GCP resources are organized hierarchically. In this sample resource hierarchy, organization node is the root node in the hierarchy. The projects are the children of the organization, and the other resources are the children of the projects. Each resource has exactly one parent. Folders level is optional for additional grouping and isolating between the projects. Before I summarize how to set up policies at each level, let's take a look at how IAM works first. With IAM, you manage access control by defining who has what access for which resource. IAM policy defines and enforces what rules are granted to which members, and this policy is attached to a resource. A policy is set on a resource. Each policy contains rules and rule members. Rule is a collection of permissions with the format service.resource.verb, for example, pubsub.topics.publish. There are three types of rules: basic rules, owner, editor, and where. The predefined rules are the rules that give a fine-grained access control than the basic rules. You can also create custom rules to the needs of your organization when predefined rules don't meet your needs. In IAM, you grant access to members. Members can be a Google account for the individual users, service account for an application instead of individual end user, Google Group, a named connection of Google accounts and service accounts, Google Workspace domain, a virtual group of all the Google accounts, Cloud Identity domain, like a Google Workspace domain without access to Google Workspace applications, all authenticated users, a special identifier to represent authenticated user with any GCP account, and the all users, a special identifier to represent authenticated and unauthenticated users. Now, if you look back on the GCP hierarchy, you can set up policies at organization level, project level, and resources level. Resources inherit policies from their parent. Resource policies are a union of a parent and a resource. If a parent policy is less restrictive, it overrides a more restrictive resource policy. If you want to learn more of the IAM and security of each individual Google Cloud service, you can review this service's last-minute cheat sheet video in my channel. You will have some questions on IAM for the cloud billing in the PCA exam. Now let's move to the cloud billing. There are two types of relationships govern the interactions between organizations, cloud billing accounts, and the projects: ownership and payment lineage. Ownership refers to the IAM permission inheritance. Payment lineages define which cloud billing account pays for a given project. Here's a summary on the IAM for the Google Cloud billing. You can set up an IAM policy at organization level, the cloud billing account level, and the project level. The billing rules defined in the Cloud IAM. On the organization level, you can create a billing account creator, which create a new billing accounts. On the organization or billing account, you can have a billing account administrator, which manage but not create accounts. Billing account user, which link the projects to the billing accounts. Billing account viewer, which will view the billing account cost information and transactions. On the organization folder or project level, you can define the project billing manager, which is link the project to from a billing account, but no access to the project resources. I highlighted the IAM best practices for the exams, but you should review the details in Google Cloud documentation if you have time. The first one is the principle of the least privilege, that you should always apply the minimum access level required. When you use a service account, make sure to rotate your service account keys. Be careful not to confuse the encryption keys with the service account keys. Don't check in the service account keys into the source code or leave them in the downloads directory. Use the logs from Cloud Audit Logs to regularly audit changes to your IAM policy. Export audit logs to the cloud storage for long-term retention. Restrict log access with the cloud login rules. Use logs from Cloud Audit Logs to regularly audit access to the service account keys. Set organization-level IAM policies to grant access to all projects in your organization. Grant rules to a Google group instead of individual users when possible. Now let's move to the key management and data encryption. You can manage your keys with the Google Cloud KMS. Cloud KMS performs cryptographic operations and manages cryptographic keys. KMS is not a general-purpose secret store. You should use a secret manager for that capability. Cloud KMS resources include key rings, keys, and key variants. A Cloud KMS key is a named object containing one or more key variants, along with the metadata for the key. A key exists on exactly one key ring tied to the specific location. The keys can be backed by software, hardware, HSM, or external system, EKM. A key's type determines whether the key is used for symmetric or asymmetric cryptographic operations. From IAM rules principle standpoint, you should avoid the basic project-wide rules using the Cloud KMS predefined rules for the least privilege and separation of duties. You need to manage the life cycle of your keys. The key management life cycle is divided into 4 phases: pre-operational, operational, post-operational, and destroyed. In the pre-operational phase, you can do key import or key creation, both symmetric and asymmetric keys in the Cloud KMS. You can store keys which are created from software, HSM, or external protection levels, or perform the key rotation in the operational phase. Cloud KMS also supports key destruction and recovery in the post-operations phase. Next one is data encryption options. Google Cloud supports server-side encryption. The encryption occurs after Google Cloud receives your data. The data is encrypted at rest by default. Besides the standard Google managed encryption keys, there are 2 extra kind encryption keys: customer supplied encryption keys, CSEK, and customer managed encryption keys, CMEK. With the CSEK, you can create and manage your own encryption keys. Use your own AES 256 in the standard base 64 encryption keys with the GCP services. Keep the keys on the premise and use them to encrypt your cloud services. You provide the keys as the part of the API service calls, or the customer keys provided via the customer-side WOTO configuration file for the Google Cloud storage. GCP uses the key in the memory and does not write it to the storage. Keep in mind CSEK is not currently supported by cloud storage transfer service, Dataproc, Dataflow at the time, and it is not available in all locations at the time of this video. With the CMEK, you can manage your encryption keys, which are generated for you by the Cloud KMS. Keep the keys in the cloud for directly use by the cloud services. You can create, rotate, automatically rotate, and destroy symmetric encryption keys. The other encryption is a client-side encryption. You encrypt the data on-premise or in your own application before it is sent to the GCP and decrypt it after it has been retrieved. If you use the customer-supplied encryption keys or the client-side encryption, you must securely manage your keys and ensure that they are not lost. If you lose your keys, you are no longer able to read your data, and you continue to be charged for storage of your objects until you delete them. You can encrypt disks with the CMEK and CSEK, but here are the 2 restrictions. You can encrypt only new persistent disks, images, and snapshots with your own key. You cannot encrypt existing resources with your own key. You also cannot use your own keys with local SSDs because the local SSDs do not persist beyond the life of a virtual machine. Local SSDs are already protected with an ephemeral encryption key that Google does not retain. You can review Google Cloud Network Connections Decision Tree and Google Cloud Load Balancers Decision Tree videos to get more information on the network in the GCP. If you need the knowledge of the network in the other public cloud platforms, for example, in the AWS, then you should review this article, Google Cloud for AWS Professionals Networking, to save the time to learn the network in the GCP. In this video, I will only highlight the GCP shared VPC and VPC network peering. Let's take a look on the VPC network peering first. VPC network peering allows private IFC 1918 connectivity across two VPCs regardless of whether they belong to the same project or the same organization. For example, you can set up a cross-project or cross-organization VPC network peering. It is a decentralized or distributed approach to multi-project networking. It does not incur the network latency, security, and cost drawbacks that are present when using the external IP addresses or the VPNs. VPC network peering connection is not transitive. For example, if there are three VPCs, then you need to create three connections peerings among them. For example, you need to create a peering between the VPC A and the VPC B, then the VPC B and the VPC C, and also the peering between the VPC A and the VPC C, because the connection is not transitive. Google Cloud also ensures that there is no overlapping subnet IP ranges allowed across the VPC networks. So you can imagine if there's more VPCs, and then the connections configurations will be very complicated. Is there a way to centralize the common resources management? Yes, then let's move to the shared VPC. Shared VPC connects resources from multiple projects to a common VPC in an organization so they can communicate with each other securely and effectively using the internal IPs from that network. Shared VPC is used as a primary networking topology to enable centralized management of firewall rules and connectivity, useful for a service that must use resources from separate projects for independent accounting and billing. A project that participates in a shared VPC is either a host project or a service project. A VPC network peering allows peering with a shared VPC. So let's take a look at this example of VPC network peering with the shared VPC. You can see in this diagram, network SVPC is a shared VPC network in the host project P1. Service projects P3 and P4 are able to attach VM instances to the network SVPC. Network SVPC peers with the network A. So as a result, you can see the VM instances in the shared VPC service projects that are using the network SVPC, VM3 and VM4 have the private internal IP connectivity with any endpoints associated to the network A. VM instances associated with network A will have private internal IP connectivity with any endpoints associated to the network SVPC, regardless of whether those endpoints live in the host project or in a service project. It is possible to set up a VPC network peering between the two shared VPC networks. I summarized the difference between shared VPC and VPC network peering for you to make the decision for a particular situation. You can only set up a shared VPC in the same organization, but you can set up a cross-organization VPC peering. Shared VPC is a centralized approach. to multi-project networking by configuring the security and network policy in a single designated VPC. On the other hand, VPC network peering is a decentralized approach that each VPC network can remain under the control of separate administrator groups and maintains its own global firewall and routing tables. This is all we have on the cheat sheet of the security in GCP. You can find more documents, guides, white papers, and blueprints of GCP security in the Google Cloud Security Best Practices Center. One of the white papers that you should review before your certification exam is the Google Cloud Security Foundations Guide. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to my channel. Let me show you how to complete the solution architecture design for one of the professional cloud architecture sample case studies, Monkerk Games. Google did provide a worksheet template for you to use to practice analyzing cases. The worksheet has the business evaluation and the technical evaluation two parts. The business evaluation has 3 columns with client, values, and immediate goals. The technical evaluation also has 3 columns with the existing environment, technical watch points, and the proposed solution. You can definitely use this template to prepare for your PCA exam, but I want to show you my solution-oriented way to propose the solution for this case study and how I draw the final architecture diagram. Are you ready? Pause the video if you need more time to read the case study. I will circle out the issues or requirements in the case study. Then I will list the possible service solutions for each of them and how I made the decision if there's more than one service for each item. End of the service evaluation, I will show you how to consolidate these services into one architecture diagram. Monkerk Games makes online session-based multiplayer games for mobile platforms. In the executive statement, they also want to collect KPI and other metrics to do future analysis. Google did provide a mobile gaming analytics platform reference architecture. I will leverage this reference architecture with the enhancement on game backend platform and game analytics platform for this case study. I mentioned this reference architecture in BigQuery's cheat sheet. You can pause the video if you need to go through the reference architecture first. Now let's take a look at the compute choice for the mobile platforms. You can choose from a Firebase, GCE, GAE, and GKE as I mentioned in the Google Cloud Compute Decision Tree video. GCE, GAE, and GKE technically all can resolve the current issue on global scaling. However, the requirements didn't mention any refactoring code for the containerization, so the GKE is out of the choice. Also, the game servers will run hardened Linux distro, so the GAE with cloud endpoints will not meet the specific OS requirement. They also want to do some server-side integration. So based on all these requirements, the GCE, Google Cloud Compute Engine, with the managed instant groups will be the good choice. In the front end, you will using the HTTPS load balance as your global load balancer for the traffic around the world. For the scan up and scan down, you will using the stack drive, now called cloud monitoring, with the custom metrics to scan up and down. So this is our choice for the compute engine. Now let's move to the second one. Is on the database. They are using a centralized MySQL database for reporting. This is not a very good idea to using the relational database for OLAP than for the reporting, because they need to run the intensive analytics through the ETL tool, and they also wanted to replace MySQL Since there's no data processing pipeline such as Spark or other Hadoop ecosystem in the on-premise environment mentioned in the case study, so I will use the data flow instead of data prog as a data processing with the BigQuery for the OLAP and the data storage. Also, the BigQuery is okay to store in the 10 terabytes historical data, and the BigQuery also supports the queries access. You can check my video on the data flow versus the data prog for the comparison summary on the data processing pipeline. The next one is they mentioned they want to integrate with and manage the NoSQL database. They wanted to store the game activity in a time series database. The fully managed Google Cloud service for time series database is Bigtable. You can query a Bigtable from a BigQuery by creating a table in the BigQuery's dataset linked to the Bigtable data source. Also, the data flow collector for the Bigtable makes it possible to use the Bigtable in a data flow pipeline. So the Bigtable, BigQuery, and the data flow provide the possibility for data preparation or and data transformation for any future analysis. We can use Cloud SQL or data store to manage user profiles, but the best choice for manage game state is the data store. So instead of managing two different transactional database servers, I will use the data store to manage both the user profiles and the game state. The last requirement is we take a look on how we are gonna processing the incoming data directly from the game servers, also processing the files uploaded by the user's mobile devices. You can send the mobile event messages directly from the end user device running the mobile app to the PubSub ingestion layer, or to go through the game server. The main benefit of going through the game server is that the authentication and validation is handled by your application. PubSub also can buffer the live and later data. The processing files from a mobile device will upload to the cloud storage. We're gonna choose the multi-region standard storage bucket for holding the data. Data flow can do both real-time and bulk processing. Congratulations, the evaluation is done. Now let's draw the proposed solution architecture. I'm using Lucid Chart to draw it. I find it very easy to use. You may use other tools, that's okay. Here's the architecture diagrams looks like. You can see the mobile application with HTTPS load balancer for global traffic. Game servers use GCE with managed instance groups. Stackdriver login with custom metrics to scan up and down. Bigtable manages game activity. Data store manages user profiles and data state. By the way, you can move the game state into BigQuery if you need to do any future analytics on the game state. Use PubSub to ingest event messaging and buffer the live and any delay data. Use data flow for processing real-time streaming data and bulk upload files in the cloud storage. Use the BigQuery data warehouse for OLAP. This architecture also can be extended with BigQuery ML for deeper insight of usage patterns forecast. You can use the BigQuery data for BI reporting tools such as Data Studio, Looker, or Tableau for visual analytics and dashboarding. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to my channel. Let's take a look at the professional cloud architect sample case study Dress for Win today. In this case study, besides proposing the solution architecture, I want to show you the important thing when you move from on-prem into public cloud, how to make your migration plan, and how to move towards a DevOps model with CI/CD pipeline. So this is what achieve Dress4Win's goal to fully transition from on-prem into public cloud and reduce the cost, free them from infrastructure management so they can only focus on developing the features. You can check my previous video on the Monkerk Games case study. That video was focused on how to propose and draw a solution architecture diagram. In this video, I will focus on leveraging the existing Google Cloud Reference Architecture and replace the on-prem service with Google Cloud Service when you are migrated from on-prem into Google Cloud. Are you ready? Pause the video if you need more time to read the case study. Dress4Win wanted to do POC proof of concept in its dev, test, and DR environments in Google Cloud before fully migration to the public cloud. Now let's take a look at the existing technical environment and how to replace them with Google fully managed services. Keeping in mind that proposed architecture needs to have a high availability and DR capability. The first one is the databases. They are using the MySQL in one server for user data, inventory, and static data with a 10 terabytes size limit. So you can use in Cloud SQL to replace MySQL in single region and create a replica server for migration. The company also cultivates the active social network, so I will using the Redis to hold its social graph, metadata, and caching. Google provides a cloud memory store for the Redis instance, replicated across 2 zones, and provide a 99.9% availability SLA. Dress4Win has web and mobile applications, so I will using the Cloud File Store for the mobile backend. Since the Cloud File Store offers offline support for mobile and web, so you can build responsible applications that work regardless of network latency and internet connectivity. The second part is compute. They have 40 web application services, provide microservices-based APIs and static content. You can pick up from GCE, GAE, and GKE as I mentioned in the Google Cloud Compute Decision Tree video. GCE, GAE, and GKE all can scan up and down. Now let's go to the Google Cloud Solution Architecture reference website. I wanted to show you their reference architectures that you can leverage for this case. Go to AppDev. Then there are microservices with GKE and microservices with the App Engine that you can borrow to use. Let's take a look at microservices with GKE first. If Dress4Win can refactor its architecture and codes for containerization, then they can deploy the microservices API into the GKE to let GKE handle the scaling and repairing in its daily operation. GKE also can integrate with the other GCP services, for example, relational and non-relational storage, caching that I just mentioned in the database replacement, messaging, and others you will see in the other computer technical stacks replacement later. This architecture also set up the connection to existing on-prem with the Cloud Interconnector or the VPN. Since Dress4Win will not finish its public cloud migration in one phase, so you do need the Cloud Interconnector or VPN for connectivities to the current environment with the firewall rules set up. Now let's take a look at the microservices with App Engine. You can see the App Engine also provides built-in load balancers, automatic scaling, fully integrated logging, etc. It is also integrates with the other GCP services for the existing technical stacks replacement. However, I prefer the GKE because I will show you the DevOps model with GKE and Jenkins later. You can get Nginx from Google Cloud Marketplace. It supports both the GKE and the App Engine, so I will put address for when refactoring the architecture and codes for GKE in the migration plan. The next computer stacks are Apache Hadoop and Spark services. Google manages the service for Hadoop and Spark is Google Cloud Dataprog. Pay attention to best practice of Dataprog migration, such as separate storage and compute, simplified workloads, simplified storage capacity if applicable. So we will use the cloud storage instead of HDFS to reduce the disk requirements and save the costs. Use the big table to replace HBase, use BigQuery to replace Hive, or use it for the data analysis and real-time trading calculation. The executive statement mentioned the just for wings traffic patterns. They are highest in the mornings and weekend evenings. 80% of our capacity is sitting idle during the other times, so you can configure Dataprog clusters to scan up and down based on the utilization demand. Now SLA critical workloads can be run on the preemptible VMs. You can use the Cloud Composer to schedule the Spark jobs. Check my last minute cheat sheet of Dataprog videos for more details. The next one is RabbitMQ for messaging. I will use the PubSub to replace RabbitMQ for messaging. I will use the cloud function to trigger social notification and events. If there is any batch processing, you can use Cloud Dataflow. I mentioned the PubSub, cloud storage, cloud data flow, and BigQuery architecture for real-time and batch processing in the previous Mount Cook Games user case. You can check that video for the details. After we replace the above existing technical stacks, I don't think you need any extra GCE VMs for monitoring. Google Cloud Monitoring and Logging will handle it. Each Google Cloud Services provides IAM and security controls, so I don't think you need any extra security scanning application. However, if you do have, put them in the GKE. I wanted to show you the Jenkins on GKE architecture that you can leverage for moving towards DevOps. Go to DevOps and open Jenkins on Kubernetes engine. This architecture isolates the dev and production environment. JustForWin can leverage and extend this architecture by creating one project per environment with IAM set up for their staffs to have different access permission. You can check the details of this solution in Google's article. For storage replacement, you can check the details on GCE storage options comparison and how to replace on-prem storage in GCE storage option video. You can use local SSD for VM hosts for better performance, SSD persistent disks for SAN. You can use FileStore, GCS, or persistent disk to replace NAS. The cheapest solution is cloud storage. You should set up multi-regional buckets to support disaster recovery. Last one, if you need more control over the keys used to encrypt the data in the Google Cloud project, you can use the Custom Manager Encryption Keys CMEK within the Cloud KMS for this requirement. Overall, JustForWin needs to make a multi-phase delivery migration plan with at least 3 phases. Phase 1 will build dev and tester environments. The least critical components will go first, such as microservices, APIs, static web application, Cloud SQL, and cloud storage. Code refactoring on microservices, APIs, web application, mobile application for GKE deployment. Leverage Jenkins on GKE for continued deployment. Phase 2 will focus on migrating messaging, real-time and batch processing, data warehouse, non-SLA critical workloads. Phase 3 will focus on critical workloads, production and DI environments build up, practice performance optimization, and failover test before go live. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to my channel. Let's take a look at the Professional Cloud Architect Sample Case Study Terraform Earth today. The business agility is automatic goal for Terraform Earth. It also mentioned lack the skills to undergo to the next wave of the transformation. This is related to the culture change during public cloud adoption, such as how to change the management team's mindset and what kind of training plan will be so the team is ready for public cloud adoption. Those should be included in the migration plan. Please check my previous video on Dress4Win case study on how to make a migration plan and how to move towards the DevOps model. In this video, I will show you how to perform architectural refactoring on this case study. Please subscribe my channel and activate the bell notification so you don't miss any new videos. Are you ready? Pause the video if you need more time to read the case study. I drew the existing technical environment with a lucid chart, the same tool I used to draw Mount Kirk Games architecture diagram. You can check that video for more details. Let's take a look at the current on-prem environment. The existing technical environment resides in the US West Data Center. There are 20 million steel vehicles. Their data stored locally. Collect 120 fields of data per second. The data is downloaded via a maintenance port. Data is 3 weeks delayed. Costs wait up to 4 weeks for their replacement parts. Another 200K vehicles are connected to a cellular network. Data collected directly, 120 fields of data per second, 22 hours of operation per day, with a total of about 9 terabytes per day from those cellular vehicles. Then the data ingested through Python application, either via FTP from the steel vehicles GZIP CSV files, or real-time messaging from cellular vehicles direct data collection. Python application does the ETL and write the data into a single PostgreSQL Server data warehouse with a total of 24 terabytes. Then 2 analysts of a team of 10 to run daily report to see what equipment needs repair. Now let's base on business requirements and technical requirements to refactor architecture for cloud adoption. Google Cloud provides cloud IoT data analytics and machine learning architecture. Let's use this architecture to refactor the on-prem environment. First, you need to convert all vehicles to cellular and use Cloud IoT Core to handle the front end. Cloud IoT Core is a fully managed service to easily and securely collect, manage, and ingest data from global dispersed devices. It establishes two-way communication with your devices, so it will decrease the wait-up time. Then Cloud IoT Core uses Cloud PubSub for real-time messaging to ingest data into Cloud Data Flow for real-time data processing. Next, using a multi-region BigQuery to replace the single PostgreSQL data warehouse not only decreases latency but also improves the availability and durability. The recovery and failover process is managed by BigQuery. Integrate BigQuery with Data Lab or the AI platform as needed to train any ML models to anticipate the customer needs. Please check my video last-minute cheat sheet of Google Cloud Machine Learning on BigQuery ML, AutoML, and Google pre-trained models. The last one replaces reporting application by using BigQuery data with Google Data Studio or partner BI tools for visual analytics and dashboarding. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.